How's it going, everyone? Welcome back to the channel. I did a previous video on SCADA systems, and there were a lot of different questions as to how the data travels between PLCs and SCADA systems, and what is the difference between PLCs, SCADAs, and HMIs. When do you choose of using one versus another? So I thought we'd have a conversation on PLC to SCADA and ultimately break down some of the data communications, break down some of the architectures, explain when you would typically transition or name something an HMI versus a SCADA system, and ultimately give a little bit more clarity based on my experience in manufacturing, explaining some of these nuances. So let's start with the PLC, right? And I have a lot of different variations of PLCs that you can see on my left hand side here. I have some Rockwell PLCs, I have some Siemens PLCs. There's going to be a lot of different brands, but ultimately a PLC is going to be a physical piece of hardware that's going to control the system on the plant floor, right? So you have your PLC, and typically you have your I/O points or inputs and outputs that will be connected to different field devices, right? And those are going to be, so again, I'm just going to draw this as best as I can on the whiteboard. You'll have different terminals. Usually you can have 16 points of inputs or outputs. You can have 32, you can have 8. Again, it depends on your system, but those are going to be connected to your sensors, right? So this is going to be inputs, where it's a proximity sensor that's going to see, it could be a box, it could be a sprocket, it could be a valve, right? So there's going to be a lot of different examples. That's not necessarily the point of the video. You're going to control the outputs, right? So here on the output side, you can have, for example, motors. You can also have valves, like I've mentioned. You can have pumps. You can have a variety of pneumatics, for example, that will be controlled by your PLCs. But ultimately, your PLC's main task is to control the process on the plant floor. Thank you so much for watching our channel. If you have a moment, I would truly appreciate if you could subscribe and like the video. If you could also leave me a comment as to whether the content is interesting for you, or if you would like to see something else in manufacturing industrial automation. It helps us tailor some of the future videos. I will also mention that we have a ton of different tutorials and articles that go way beyond the content on the joltech.com website. If you need help on some of your projects, don't hesitate to reach out. With that in mind, let's get back to the video. PLCs are, or can be thought of as, highly advanced and highly reliable computer systems that are optimized for running a process 24/7, 365. So the main goal is to run the process 24/7, 365. And so ultimately, this means that there will be certain restrictions placed on how you can design and program this type of system. It ultimately means that you also have a series of different constraints that other systems may or may not have, and supplement your PLCs running the control system. So for example, your PLCs are going to be extremely fast. So from your input side going into the PLC and then actuating the motor, it could be milliseconds, right? So depending on how long it takes to run the logic, sometimes it's milliseconds and it's going to activate your output. Similarly, there's going to be high-speed input and output cards that will react very quickly. You also have safety modules, right? So safety is going to be a very important component, but what I'm trying to say here is that the PLCs are first and foremost optimized to run a process that needs to be precise, needs to be accurate, and needs to be repeatable for a number of days, hours, years, and some of the PLCs will run for basically decades. Now, on the other side, you have, as you start to think about the design of your system, you're looking to have an interface for someone to change parameters, perhaps reconfigure some of your system options, see the status of your system, and understand what is going on. So on this side, I'm going to draw out a HMI, right? So this is HMI. And so on HMI, again, there's going to be a few protocols that you can connect the two together with, but ultimately there's going to be data between HMIs and PLCs that primarily allow you to start and stop the line, start and stop a certain piece or component of that line, maybe adjust, like I've mentioned, some of the set points. So for example, if you have a brewing operation, maybe you need to adjust the temperature setting, maybe you need to adjust the time setting for how long a certain batch is going to cook. But ultimately, the HMI is the interface between the operator and the PLC. Of course, the same can also be done via a programming terminal, right? So if you're an engineer working on PLCs, chances are you have a laptop that you can connect with, and you can make the exact same changes that an HMI would, but ultimately it facilitates how the operator uses the system, understands the system, troubleshoots the system, and basically works on the machine rather than trying to figure out the registers and the tags and some of the nomenclatures used inside of a PLC. Now, as we move forward to SCADA, right? So what is a SCADA? Well, first and foremost, as I've explained, the acronym obviously stands for Supervisory Control and Data Acquisition, but we need to expand a little bit more on that. So supervisory, what does that mean? So to supervise, again, the HMI will accomplish that task. The HMI will monitor the status of the PLC, but also monitor the status of the underlying system. Is it running? Is it faulted? Is it stopped? Is it producing? How many cases is it producing? So it is supervising the process. The HMI is going to do usually a very good job at monitoring the local system that is immediately tied to the PLC. SCADA is going to be a step above, where it can supervise in a general sense multiple such systems. So there is no hard rule as to where, if you deploy, for example, a SCADA. So again, I'm going to create another drawing. So let's assume that the SCADA is going to run on servers first and foremost. So SCADA, and then SCADA will be presented to a number of terminals. If you have seen basically control rooms, right? So let's assume that this is a bigger room where you have multiple screens here. So you have 4 different screens that basically depict different areas. And so imagine that this is now controlled by or presented by the SCADA. You can think of them as basically HMI terminals on a slightly larger scale. So there is no hard rule as to when the SCADA or the HMI becomes the SCADA, or when the SCADA becomes the HMI. Going back to the functions though, so the HMI, like I said, is a terminal that allows the operator to work on that specific machine. The purpose of SCADA is going to be a couple of things, and we've talked about the supervisory control, right? So again, both the HMI and the SCADA are going to have a control component. And this becomes extremely important as we talk about some of the higher levels. So when you're talking about systems like MES or ERP, in most cases, they will not have a control component. What does control actually mean? Well, control means the capability of starting, stopping, and adjusting the process while it is functioning, right? So again, if your operator walks up to the HMI, there's going to be push buttons that allow him or her to press and start the machine or stop the machine. The SCADA will also have those push buttons, right? And I say push buttons, but they're going to be digital buttons, usually on a screen. Of course, you could have a terminal of physical buttons, but in this case, it is a digital button that allows you to send a start signal, right? So again, so it's going to send start into a register of the PLC, of course, execute the logic, and then start, the motors, the valves, what have you. But basically, both of them have that capability. And data acquisition. So data acquisition is the very important component of any system, I would say, at least in this day and age, because everyone's trying to understand the data on how the system works, on the performance of the data, on the performance of the process, on troubleshooting, right, on what went wrong with the system should it fail. And so ultimately, how do you get that done? Well, first and foremost, your PLC is going to be the source of raw information or raw data as it comes in from your field devices, right? So as we've discussed, there can be sensors. In this case, let's assume that it's a digital input, right? So it can be 0 or 1, depending on the presence of a box, for example, or again, there's going to be a lot of different examples in different devices, but it can be a logic 0 or a logic 1 represented within the PLC registers, right? And I'm drawing these out, but ultimately it is stored in the memory of your programmable logic controller. Similarly, the outputs are going to have similar registers, so 0 and 1 for running or stopped, but it goes a little bit more beyond that, right? And I'm oversimplifying how this ultimately works. If you have any questions, make sure to leave them in the comments. But there's going to be speed references. So for example, speed is going to be, let's say, 0 to 100 hertz, right? And that's going to dictate how fast or how slow the motor is spinning for whatever application this is, right? Maybe it's a mixer and it steers the product within some kind of a tank. But what I'm trying to get to is there's going to be a lot of different registers within your PLC to help execute the process. And so those registers can then be presented on the HMI. So for example, we can have the sensor that is activated that will set off some kind of a maybe message here, right? So box present, and that will be displayed on the HMI. As I've mentioned, that is raw data. That is the simplest form of information that you can collect and send to the plant floor. Your PLC is going to be a lot more capable than that. And if you have done any amount of PLC programming, you will know exactly what I'm referring to. And let's take a simple example. So if we have a box, basically present sensor, well, we can create a counter, right? So CTU, count up, that will increment based on how many boxes we have seen in the last hour, in the last shift, maybe in the last week. And so this is going to become boxes, and this becomes a counter, right? So let's say it's like 164 at this time. This is data that is generated by PLC. The only thing that is raw information is going to be this sensor that's going to trigger from 0 to 1. But in this case, we need to combine the counting principle, but we also may want to combine the time, right? So your PLC is going to have a register for time. And so from 8 a.m. to 9 a.m., it's going to count 164 boxes. From 9 a.m. to 10 a.m., for example, it's going to count 74, so on and so forth. So your HMI can also have a set of registers that will display that information, right? So here, 8 a.m., 9 a.m., so on and so forth, so that the operator can understand the data beyond just knowing when the sensor turned on or off. So this is a piece of information that needs to be created by the programmers to help the ones operating the system understand what is, again, the productivity, what it has failed on, and what are some of the opportunities for improvement. And so I've given you one example. It could be fault codes for these different motors. It could be logging the speed of your specific motor and or multiple motors and pumps and so on and so forth. But ultimately, the HMI is more than capable of storing and presenting some of that information within its registers. Your SCADA system, likewise, can also ingest some of that information, right? And in this case, I drew this graphic like this, but imagine that the data is also being passed to the SCADA system for storage and presentation, right? And so it's going to create its own registers. So this is 8 a.m., this is 9 a.m., so on and so forth, so that the users can see what is happening, and if the system goes down, of course, they can restart. Now, the question becomes, why do we need SCADA? Why do we need an extra layer of architecture that we can be doing on the HMI? And so this goes back to the main, basically, problem or the main thought when we had what is the purpose of this specific system. And remember that the goal of the PLC is to run the process 24/7, 365. The main purpose of the HMI is to allow the operator to basically work on the machine locally. The goal of the SCADA is to control a larger area or larger set of PLCs, but also to store and present historical information. And so why is that not possible with just PLCs and HMIs? Number one, your PLCs are usually going to be low on memory. Because they are expected to run on a such frequent and such fast basis, they do not have a lot of memory for registers to store and basically historize the information. So a lot of times you can create the register for your boxes for 24 hours, maybe up to a week, depending on how many registers you want to record. But ultimately, there's not going to be a sufficient enough space for you to save the state of your sensor every millisecond that the cycle of the PLC continues to update. Do you want that information? That's a whole separate discussion, but ultimately here, your PLC is low on memory, so low memory, which basically means that any data structures, any arrays, any batch, for example, applications are going to be very difficult to run on the PLC on a scalable fashion. Of course, there's going to be exceptions to the rule. Like I said, you can buffer some of your data for a certain period of time, but you probably don't want to use your PLC as your database. The same goes for your HMI. So in general, your HMI is going to be a smaller computer that will have a form factor that allows it to be mounted on a panel or a pedestal where you can come in and actuate certain registers and view the information about the platform. But they are not, again, they are not a storage or they are not a data backup and storage device. There's of course some nuances, and I've talked to many manufacturers about this, right? So you can plug in, for example, a USB key into your HMI and retrieve some of the information. You can also, so this is USB, you can also use an SD card, right? So this is a common occurrence for smaller machines. If you want to create a backup maybe of the last week's operation, that is perfectly fine. You can deploy a small database on your local HMI that will store some of the data that you're collecting from the PLC. Once again, you do not have the same, I want to say, cost on data as you would with a rack-mounted server solution that you will typically see for SCADAs, right? And so in this case, I have drawn out a server rack where you can basically lay out, and again, I'm not sure how many are familiar with server rack technologies, but you can basically stack hard drives one after the other. You're starting to have access to features like SSD versus HDDs, or solid state hard drives versus your normal spinning disks, that allow you to basically store to some extent infinite amounts of data relatively cheap as compared to storing or doing that inside of your PLCs and HMIs. And so as you start thinking about the journey of PLC to SCADA, your main goal is to understand what is the purpose of that specific system. Can you develop a batching system inside of your PLC? The answer is yes. Can you store all of the configurations or SKUs or parameters inside of your PLC? The answer is generally yes, maybe yes, but it's probably not something you would want to do if you want to build and design a scalable system. What you would rather do in that specific instance is run the software on the servers and have the SCADA store a lot of the data when it comes to how that batch has performed. Similarly, as your HMI applications begin to grow, there is a general consensus that you can migrate to a server SCADA solution that would allow you to facilitate development, facilitate deployment, and ultimately make it a little bit more flexible when it comes to deploying